Hello everyone, my name is Huanyu Zhang. I'm from Meta, so I'm a research scientist. Today, I will stand on behalf of our podcast team to give this introduce some exciting new features and also our future development plan. So just in case you don't know Alpaca, is one of the largest and the best developed open source implementation of DPHGD. So it has the following several benefits. First, it's compatible with most of the PyTorch models. It requires minimal code changes, that's very easy to use. And also it supports a lot of advanced features such as a virtual mini batch. Furthermore, it has already been exhaustively tested, so it's very stable and robust. Okay, so I'm excited to announce that after roughly 1 year of maintenance mode, we are bring some new features in Alpaca version 1.5. So as already been promoted by Ilya in this morning, we brought ghost clipping and fast grading clipping into Alpacas. I want to thank a lot to my intelligent team member Inayat, who is sitting over there. So with his efforts, made it possible. So by post clipping and fast grading clipping, as you know, DPIGD is very poor in using per sample gradient, and the memory will be much larger than PyTorch. By this new feature, we will greatly reduce the memory. So we see roughly 95% in our internal use case. Or in other words, you will use 20 times larger of the batch size in your Euro compared to the vanilla alpacas. And also in real practice, although it has introduced a second backward pass, we don't see much. Sorry, who do we go back to? Yeah, we do not see a real QPS degradation. And also we believe this is a first but very important step towards training large scale DPIGD models and also real deployment for practice. Finally, I want to talk about some future developments. So first, we will continuously improve ghost clipping. So we will bring even advanced algorithm like bookkeeping and also ghost differentiation into alpacas. Second, so for now, we see some embarrassing gradient misshaping, alignment. So in the alpacas, we will fix that to make sure we support most of the common LLM model architectures. And finally, we will continuously improve the scalability by using a model parallelism and also a mixed precision calculation to further improve the memory and the QPS. I believe I should have 1 or 2 minutes more, so I'm happy to take one question from the audience. No question? Is that allowed?
No question. Sorry.
Okay, it's fine. So feel free to find me in the break. So I'm happy to answer take more questions.
All right. So, hi, everyone. My name is Nicolás Berrios. I was an intern at OpenDP in 2023 and at Oblivious in 2024. And I'm here to share with you a joint project between these two organizations known as the Differential Privacy Deployments Register. So just keep in mind, this is an open and ongoing project. So keep an eye until the end to learn how you can contribute, and feel free to reach out on any of the breakout sessions. So one of the problems we find with institutions trying to deploy privacy systems is that they're having trouble just basically agreeing on what epsilon value to use. And in practice, what they see them do is that since this is not only not a solved problem, it's most of something that you need to consider multiple variables like the frequency of the release or what model of DP you're using. We see them reaching out to different of the big players in the game. And maybe engineers and managers or researchers like us can understand the implications of using different epsilon values, but ultimately you need a way to communicate this to a non-technical audience, like for example, regulators, lawyers, or other members of your institutions. So right now, as I was mentioning, most people are just reaching out to other big players and comparing how their epsilon value plays out between them. So the main takeaway that we see is that they don't want to stick out. They want to stay in the middle of the batch. Like they don't want to have the highest epsilon value of any other institution, but also they don't want to go to the other complete end where they would lose all the utility for the use case. So trust me, as an engineer or as a manager, if you had the chance to go to one of the stakeholder meetings, you'll know that there's no epsilon value or accuracy metric that would get the point across as best as just saying, hey, this is the other big player. It's doing something similar to us. We're using somewhat the same parameters, or we're actually doing better than them. So that's why we created the Differential Privacy Deployments Registry. And we want to have this unified resource for institutions to first share their epsilon values or other privacy parameters, but also reference what other institutions are doing in the ecosystem, so we can maybe converge to this range of epsilon values that are acceptable for any of the use cases. Well, if you see on our slides, we have 2 calls to action right now. If you check on the first QR, you'll see that how our V0 looks like. That will take you to registry.oblivious.com. And we have an introduction. We have different characteristics of DP systems. But if you scroll to the end, you will see a table right similar to this one, where you can know the privacy parameters of different releases made by about 30 different institutions. And on the second QR code, you will see a form on how to contribute. We're happy to hear about your parameters, use cases, or lessons learned at your institutions. So feel free to reach out at any moment. And yeah, we look forward to continue building this Epsilon registry together at the community meeting. And we can wait to hear about your use cases at your institution. Thank you.
Okay, hi everyone. My name is Gerome Miklau. I'm CEO and one of the founders of Tumult Labs. You may have heard of Tumult Labs. We've built Tumult Analytics, the best in the world open source platform for different, no. Because I'm here, one of the best open source platforms for differentially private computation. We've helped a number of institutions get to deployment of differential privacy and high stakes applications, including Census Bureau, IRS, Wikimedia Foundation. And one of the problems that we've seen arise in virtually every practical application that we've brought to deployment is tuning is hard. Okay, so tuning involves, and this community largely knows this, but tuning involves setting not just the epsilon parameter, but also algorithmic parameters, and sometimes even adjusting the task to get accuracy that meets the demands of the application. So we've built a product to make tuning easy, fast, and hopefully collaborative. So this is an extension to the Tumult Analytics library, which takes out a lot of the sort of error-prone and annoying work involved in getting tuning done and an optimization of your algorithm. And we've taken an empirical approach to this. So essentially, we're trying to run a differentially private program multiple times, comparing it with a baseline, and allowing us to efficiently explore the set of possible parameters. So we have built-in error metrics, including drill down error metrics, which are basically have to do with measuring metrics for each group if you're doing a group by, for example. Automatic baseline computation for a DP program, which turns out to be kind of tricky and annoying to specify. And we're certainly going to let you and let our users customize metrics and customize their baselines. And we've implemented a bunch of performance optimizations as well. So this Tumult Tune product, an extension of Tumult Analytics, is in private preview. We're excited about it. Our scientists are using it. Some of our customers are using it. And it's really accelerating the tuning process for them. It's in private preview, but if you'd like to get a trial license of it, you could follow this link or this QR code. And if before doing that, you want to learn more about it, you could watch a 5-minute teaser demo where you'll see Damien give a nice demo of the capabilities of this system. If you want to find out more from me, I'll be around for the rest of the day.
All right, so hi everyone. My name is Yanis Vandecasteele. I'm very happy to be here. I'm holding this speech on behalf of myself with the support of OpenDP and mentors from Oblivious, Nexus, and NIST. Today, I chose the angle of a practical deployment of differential privacy and how to bridge the gap between theory and practice. And so I wanted to try to answer the question of, the kind of the elephant in the room today. Differential privacy does not work in practice, at least according to some people from industry who think that it's too hard to implement. you need additional resources that you don't have within your company. You are already compliant with the law. So what good does differential privacy for these companies? Our contribution was to get involved in the practical deployment of DP, and we want to share to this community all the insights from this practical deployment and step-by-step real-world recommendations that you could use right away to make DP more convenient and easier to deploy. So what was the project? The goal was to apply differential privacy on financial data from MasterCard to empower epidemiology and public health decisions in the context of a pandemic. So there are many examples of application. One of them, to make it concrete, was to track the earnings of restaurants and airlines, for example, during COVID-19, to use them as predictors for new cases during COVID. That's one example of applications. There are many others. And that's the reason why we expanded the project to be a public challenge, an hackathon, to welcome the contributions of all of you, epidemiologists, differential privacy experts, data scientists, and many other domains of expertise. It was called, to give credits, the Pets for Public Health Challenge, organized by data.org with the support of OpenDP and Javeriana University, which has a team of epidemiologists. So there are several rounds of selections of the participants. At first, they worked on mock data. They showcased their project proposals on how to use DP for epidemiology. We selected a few winners, and the current phase of the project is that we work with these winners and we want to get them access to DP synthetic data. And down the line, they'll be able to submit their DP code directly to the company. So the work of OpenDP was to provide the DP synthetic data algorithm and the baseline solution to the challenge on how to use DP for epidemiology. It raises a mosaic of challenges. One of them, obviously, is the choice of epsilon. And I believe that the work that Nicolás just presented is going towards the right direction with the epsilon registry. But to name only a few of them in the very short amount of time, I would say that there was the harmonization of knowledge across the data holders, the participants, and how to bridge to epidemiology. So we explain in the paper that will be released later this year how to tailor differential privacy specifically to the latest epidemiological research questions with the support of Javeriana University, which is involved in the paper. A second challenge was the data format. I could dig into many sub-challenges, how to work with a data dictionary, but one of them was to work with aggregate data at some point in the challenge. So we provide in the paper a very detailed pre-processing strategy that you could use and share to the company to control the truncation and aggregation process to make DP viable on top of aggregate data. And I believe this is in the spirit of adapting DP to reality, because in real settings, you know that an external company will have much trouble to share with you individual level information. To quickly go through the technical details, I don't have a lot of time, but I wanted to address a few key points. We use a stability-based histogram for the baseline solution to avoid any privacy leakage via the grouping keys, as some combinations were missing. We use Gaussian-Rossi CDP noise, and we provided and proposed in the paper an exponential mechanism to select the optimal set of grouping columns to make sure that your grouping is not too fine-grained. I believe this is a common pitfall in practice. You end up with a very small number of individuals in each bin, which makes the noise addition relatively very high compared to the signal. And so we use a utility matrix that relates to the signal-to-noise ratio. And lastly, we provide a quite original DP synthetic data algorithm to sample directly from the histogram without any extra cost in the privacy budget. So we felt that it was an efficient, privacy efficient in terms of budget, very on top of the baseline solution, sorry. And so we sample directly from the histogram. You need to imagine that you have, for each bin, the noisy count and a noisy aggregate, maybe the noisy sum of a certain signal. The algorithm we use is a bin packing algorithm, which samples n Poisson variables conditioning on their sum. So for each bin, you can sample noisy count Poisson variables conditioning on their sum being equal to the noisy sum. And to circle back to my first statement, I believe we can make DP work. We certainly already making it work with all of you in this community. And feel free to reach out by scanning the QR code to talk about the project. And thank you very much for your attention.
Hi, good afternoon. My name is Mohammed. I'm from Ford. I'm sure some of you must have heard the session that my colleague gave in the morning today. Technically, we can't really talk about the exact use case or stuff that we do at work. So what I'm going to talk about is the motivation for doing some of DP work plus pets at Ford. And the reason why we do all of this is because we collect a lot of connected vehicle data, right? Vehicle at this point is very, very smart. It can tell us the lat, long, the GPS location, your infotainment data, everything that everything that you can process will be sent back to the companies. But what we do with the data and how securely we keep the data translates into a brand trust and loyalty for us, right? For a company like Ford, which is selling hardwares and which relies on selling actual base machines, right? The better our customer loyalty is, the more we are able to sell. And at Ford, our team measures all of this using empirical metrics and all other privacy metrics that we have. But one of the biggest metrics that we really track, and a lot of other OEMs do track, is the consent rate, which is how many people have agreed to share data with us. And that tells us whether we are doing privacy right or not. Any sort of news, not just that our company, but any other general automotive data breach or any incident that happens across industry, every company gets impacted by that news, right? Every company's customers lose their trust a little bit and they go back to their device saying, hey, so I know now I don't want to share data with you guys, right? What we lose out is we lose out on a good value of the data that we can use to improve our services as well as the customer experience. So we are working towards tailoring specific solutions, improve this whole customer experience piece, and also bringing in a lot of user experience flavors to the company as well as the user. What we also have seen is, as soon as any incident happens or as soon as any news leaks or any speculation comes about any data breach, we see that 1 out of 5 users are declining their data sharing agreement with us. Even though we are putting in a lot of work in the language that we process, we lose out on our valuable data, which can't really be substituted by synthetic data, though we have a lot of different algorithms to it. Also, we lose out on a lot of futuristic sales that we can do, right? So our team does a lot of this, lot of algorithm development and a lot of other pieces to fit this puzzle and make sure as a company and as an industry, we automotive companies become more aware of privacy and become more and more reliant on using DP and other algorithms to solve our privacy related issues. So just like Sharat mentioned in the morning, we have a lot of open positions and you can reach out to either of us and get to know more about it. Really hoping to get some ideas about implementing DP and as well as other futuristic tech into our ecosystems at Ford.